Hey there, guys. We're back with dealing with some radicals here today. And we're going to take this section, we're going to break it into two, so it's going to take a while, but that makes each one a little bit shorter. Radicals are going to be key later as we deal with some trig things. It gets used in a lot of formulas. You guys have already used it. That's kind of how we solve Pythagorean theorem. We have to eventually take the square root. That's a radical. We have to do a couple of those other things. So we have just a little definition box here. Dealing with the radical, the radicand. The radical sign is just a square root. Radicand's the thing inside there. The index is, if there's no symbol there, like our square root of 36 down here, that means the index is 2. Otherwise, it's that little number kind of inside the check mark. That's the unofficial technical term on how we deal with that. Okay, so we're going to deal with some square roots. So you guys know the square root of 36 is 6. We can talk about it as being plus or minus 6. But in this case, we're just going to make it 6. Normally, when we see a square root negative, we know that something's up. But this one happens to have an index of 3, so it's a cube root. So that means we're going to deal with -2 and only -2. The square root of a negative, we know that this one is going to be a non-real. Right? We could say 2i, or in this case, we would say plus or minus, because now we're in the imaginary family instead of those real numbers. If we're asking just about the real number solution, we would say that there is no solution or no real solution for this one. All right, and then I want to make sure we threw a fraction in there because I know this is something that got maybe skipped over a little bit from Algebra 2 if you had it just last year or it's just been a long time. So cube root, and we want to keep this thing as -27. When we deal with a fraction, we can deal with it as two separate pieces. So I just took the negative and put it up top. So that means we're at -3/2 to get that final answer, dealing with cube root of 27. Okay, so in your calculator, we have a couple things you can do. You can get a place to change the index. We'll show you that in class if you're not sure how to do it. Otherwise, quick Google and you'll find that out. The TIs do have a cube root, but as we get to any other powers, there's an X root that you'd be looking for through your options. All right, so some properties that we do have, if you have the same index and you are multiplying, okay, just like we were doing the division, so what I just showed you was rule number 2, that I can separate the top and bottom. That also means that I can separate those numbers. So that's how we use that to break some things down, but we also use it in reverse to make things a little bit easier to put them together. If you have a power or a root covered by another root, we can put those together in number 3. If you have the same power and the same root, right, they'll cancel each other out and become 1, because we are dealing with those rational exponents. And we can write this. The order of operations doesn't really matter in number 5, is what they're saying is. So if it's something that you know the square root of, and then we have to cube it or whatever, then we can do the square root first and then cube it. So the order doesn't really matter. It's whatever is going to make this a little bit easier. So the numerical example over here to make that sound a little bit better is, I don't want to do 27 cubed or squared because I know 27 cubed is 3, and then I want to square that. I certainly don't want to do 27 squared and then take the cube root of it because we're looking at something a little bit larger. All right, and then the last thing is if we're dealing with our square roots, when do I have to decide if it's going to be positive or negative? Okay, so if we want the square root and the square to cancel out here, since we're dealing with -6, we'd have to use the absolute value versus if I cancel out my power and my root, if it's odd for the index, then I will be able to use exactly what we had for the negative. Okay, so odds we're going to leave alone. Evens, that's where we're going to remember that extra absolute value piece of it. Okay, so we'll run on that too a little bit today. All right. So when you think about doing the factor tree, right, my index in number 1 is 2 because there's nothing there. So the way you did this a long, long time ago is you decided what factors of 24 do you like? Do you like 2 and 12? Do you like 4 and 6? It doesn't matter. So you're thinking 4 and 6. So I'm going to write the whole thing out. And what you're looking for, since the index is 2, I'm looking for pairs. So I have a pair of 2s, so that comes out just the way it is. What's left over is 2 and 3, so I put them back together as multiplication. So then it's taken care of. Same idea. This one happens to have a 5x on the front side of it. That just means that if I get anything that comes out, like in the previous problem, the 2 came out, I'd have to multiply it by 5x. That's all that means. Okay, so we're going to ignore that for a little while, and we'll go with 18. What am I going to use? I'm going with 2 and 9. So you guys remember that this goes a little bit faster if you remember your perfect squares and find those as factors. So that means I have 3 is going to come out. So far I'm up to 15. I'm going to leave a little space for all these variables, and the 2 is left over. I like to do this piecewise, so I'd take care of all the numbers first. The next thing is we have x to the third. So that means you have x times x times x. So you have one pair multiplied by the other x. So that gives me x squared on the outside, but I do have one x left in the inside. Y to the fourth. So you can imagine 4 of those. That means you have 2 pairs. And z to the fifth is going to give me 2 of those pairs and then 1 left over. So those are all taken care of. Square root of 80. A lot of kids just say 8 and 10, so I'll go along with that. So 4, 2, 2, 5, and I get 2 and 2. So I need 1, 2, 3, 4 2s, right? Because my index is 4 this time. So I need 2, and then the 4th root of 5 is my leftover term. And then our last one. Since we're dealing with the cube root, the negative is just fine. But what I'll always do is assume this -1 is actually a set of -1s. So I'm going to put negative on the outside and then deal with the 24. So I might use 4 and 6. So that's 2 and 2 and 2 and 3. So I have these. So I'm at -2 so far. I have the cube root of 3, and then I'll go back and take care of the variable afterwards. So if I have y to the 6th, we're looking for sets of 3. So we have 2 sets of 3. And we wouldn't have any left over. Okay, so that's how we break down those radicals dealing with any of those. All right, so we only had one extra multiplication in number 2 here. Just keep in mind anything that comes out, you just multiply along with. All right, next thing we'll do is deal with some fractions here. So we have to rationalize the denominator. This is the thing we mentioned. Oh, that's not a highlighter anymore. Rationalize the denominator. This is the thing we mentioned above. It's going to be super important for trig stuff later. So what we're going to do is we're going to identify whatever is a problem. The problem for us is having a radical or a square root in the denominator. So whatever is causing the problem is exactly what I'm going to use to fix the problem. So to fix this problem, I'm going to multiply by 1. Right? That's what's happening right here. Root 3 divided by root 3 is 1. But we're going to make it look like whatever we need it to look like. And the thing we need it to look like is the denominator. After that, we're going to multiply straight across. So I'm making a pair of 3's. So I'm completely okay with taking this and going straight to 3. But today I will show you. And then if you start to skip that step, as long as the numerator comes out okay, then I'm all right with that. Because then we're also going to multiply 2 times 3. It's covered by the radical. I can multiply these because they have the same index. So all those bases are covered. All right, let's take a look at the next one. So the problem that I have is the square root of 5. So I'm going to fix this problem, 2 over the square root of 5, by multiplying by the square root of 5. Now 2 is on the outside, and root 5 is on the inside. So the top is really just 2 root 5. I have root 5 and root 5, so that's root 25. So it's 2 root 5 over top of, now I've made a pair of 5s, or you guys know the square root of 25 is 5. So we get this. Remember, I cannot reduce things inside to outside. Okay, so we're going to resist any temptation to do anything else with it. What I could reduce is if I had something here. Okay, those are things that I can reduce. All right, so we'll get rid of some of that highlighter. So that's what we're looking for. All right, next one up here. So I get 15 root 6. We're going to multiply it by the thing that's causing the problem. What's causing the problem is the square root of 6. So that's going on the top and bottom. So I get 15 root 6. And if it's okay with you guys now, we know this turns into root 36, or it makes a pair of 6s. And then this is the highlighting that I was talking about. If this can be reduced, it needs to be reduced. So root 6 is going to stay just the way it is, but 15 and 6 are both divisible by 3. So I get 5 root 6 over 2. All right, now in the next one, I might try and separate this one just to make the whole idea look okay as far as what's causing the problem. What's causing the problem, remember, is always just the denominator. So I'm going to multiply by root 5 on the top and bottom, which means I'm multiplying by 1. It's that identity property coming back. Now both of these are covered, so I do multiply them and make it root 15, and it's over plain old 5. Can I reduce these? Absolutely not, right? Because root 15 is covered by the square root, 5 is not, so this becomes our final answer in this last one. All right, so I try to take my time and make those nice and slow. So I have a couple for you to try out. I'll take a look at these in your notebook before we get into class, or just as we get in and we're working on some things. And then I do have, if you are good with some of this stuff, then I did attach your homework. So you can go ahead and work with those. This one's spaced over intentionally, so you can work answers here and here. So hopefully that helps with your space and organization. And yeah, I'll see you in class. Peace.